Now, one area of the optimization workflows that we should look into is risk analysis. And I'm going to keep it brief because I'm running just a little bit long of the target. So let's go into this our risk profile, set up some risk values for different activities, and run a simulation on those. Now, I've already defined some risk values for some of the different activities in the schedule. What you're looking at is basically a risk profile matrix at the top of the screen here. We've got all of our activities lined up on the left, and we have 5 categories of risk across the top. We have a start of scheduled task, which is the the risk of an activity starting on the day that you plan to start at. I'm going to set those all to 0. We'll assume that that we're on track right now in the foundations work, and steel erection can start on time with a 0 risk factor. We have scheduled task duration, which is the risk of an activity being completed per the planned duration. Now, if we go back and look at our calendar, we're in, let's see, some summer months here for steel erection. We got May, June, July. Let's pretend that summer months are monsoon months in this area of the world, and we perceive some risk to getting that steel erected with some potential storms and rain coming in. The way that we could represent that would be to drop this menu down. You can very simply choose from 0, low, intermediate, and high risk values, or you can explicitly define a percentage, an optimistic and a pessimistic percentage of completion there. I'm just going to pick intermediate risk for steel erection and shaking out the deck, with a low risk to welding and of the decking and the shear studs and the edge form there. I'll assume everything else is a short enough duration that it has a 0 perceived risk. Beginning risk, I'll set as 0. That's the ability of a subcontractor to show up with the right resources on the right day. Comeback delay, that risk is related to starts and stops. So if you have a subcontractor where you perceive a demobilization or a stop of work could potentially impact their ability to come back, let's say they need to leave for a week, but you're concerned that leaving for a week may mean that they actually don't come back for 2 weeks, then you can insert a risk value there to factor into the risk analysis. Production factor is another area of risk that we can evaluate. This is where we can input our perceived risk related to the assumed production. So let's say layout slab on metal deck. Let's say we're using a total station for laying out the slab on deck. We've never used a total station before. It's possible that we won't be as fast as we planned in laying out the inserts, and so I can input an intermediate risk here, and I'm going to just follow that up with a low risk for all of the inserts that follow the layout. So once you've established your risk profile, you can then run your risk analysis and your risk simulation. Now this is a Monte Carlo risk simulation. It basically runs iterations of all of the potential combinations of risk delays, be they optimistic and pessimistic. It can do it up to 1,000 times. Let's see, I'll just do 300 iterations for the purposes of this presentation. And after completing the calculations, we can view the results in a number of graphs. Let's first look at the temporal distribution of our risk simulation. Now, what this shows us is basically, it's the result of all of the iterations of completion. There's a summary up at the top that's telling us our deadline is December 16th. Currently, based on our logic and risk profile, it's expecting completion on the 15th, with an earliest on the 13th and a latest on the 21st. And the 21st is, it's going to be a week behind our deadline. What this results in is a 64% chance that we're going to finish the job on time based on our risk profile. Now, as a factor of optimization, you may want to go back into your schedule and modify some of the relationships, maybe add some buffer time between activities, maybe restructure the sequence of activities to try and mitigate some of that perceived risk. Let's say, as we look at the screen here, you can see an array of yellow, green, and red dots. Now, each of these dots, if you hover over it with your mouse, is going to tell you what the risk of meeting this date is. You can see the green dots, it's telling us there's a 30% chance that we're going to miss this date. However, you should probably focus on the red dots because in some cases we're up in the 80%, 92% chance that we're going to miss our date here at this location for welding these shear studs. Identifying those risky areas and insulating them will help you to mitigate some of that perceived risk. Now, if you take some actions to maybe add resources to activities to ramp up and to give yourself some better production on there, maybe let's take some of these activities and add some resources. Let's take this layout slab on metal deck, and instead of forcing it to be paced, let's do it as soon as possible. Now that's going to insert some starts and stops in our schedule for this activity, which again should be part of our risk profile. And so you have to make a decision on whether or not it makes sense to do as soon as possible or force the activity to be continuous. In this case, we want to mitigate the risk of overshooting our milestone date for completing the slab on metal deck. And so we had to make that decision. Let's go back into our risk analysis, run another simulation, and see if that's helped our chances of finishing the project on time. Go into our temporal distribution. All right. So up at the top now, you can see for that deadline of December 16th, we're now expecting to finish on the 8th with an earliest on December 2nd based on our optimistic values and a latest of the 12th. And since the latest projection of the 12th beats the 16th, we've got a 100% likelihood of finishing the job on time. So that's the kind of analysis you want to go through during the optimization process in structuring your schedule. The result now is a schedule that we can buy into. We've run an analysis. We've evaluated the crew flow and the sequence. We checked it in the 4D simulation to make sure that the visuals of work make sense, so that we're not installing, again, a roof deck before the steel is there. We've input some risk values for some activities where we think there might be some potential for delay either in the overall duration or the production or the starts and stops. We factor those into our analysis, and we've come up with what we feel to be an optimized schedule.